afternoon, good morning, good evening, whatever time it is you're watching this, Professor. My name is Eric Brown. Today is August the 11th, 2022. And today we will be talking about the male reproduction system with regulating of sperm reticulations and the general epithelium. Again, this is by Eric Brown, which is myself. So first, I'm just going to talk about the male reproduction system. The male reproduction system consists of the testes, the internal genitalia, and the external genitalia. And so with the internal genitalia, it includes the accessory glands as well as the ducts. The external includes the scrotum, the penis, and the testes include the sacs, which is also known as the sternum. So, the urethra, which is a part of the male reproduction system, serve as the common passage for the sperm and urine. It is not synchronous, so they come through the same thing, but they don't come out together, if that makes sense. It runs through the ventricle aspect of the shaft of the penis, and it's surrounded by spongy column of tissue that is also known as the corpus spongius. So now we're going to talk about the testes and the seminiferous tube. So the seminiferous make up the testes. About 800 of the seminiferous make up the testes. I'm sorry about the minor spelling area right there. Not Nick, it's supposed to be made. So the testes makes testosterone. It is the primary male sex hormone. It also plays a role in sperm production with the seminiferous. With the seminiferous is the site of spermagenesis, where sperm develop into spermatogenesis and close interactions with the sternatal cell. So again, this is just talking on the subject of the sperm production in the two key cells. So we have the spermogenital cell, the citernal cells, and the citernal cells are the extension from the outer edge of a tubule to the lumen. These cells rest on the basal limule, creating a basal compartment between the cells and the limule. The aspect end of the sternal cells faces the tubular limule. Adjacent to the sternal cells and a tubule are linked to each other by tight junctions from an additional barrier between the lumen of the tubular and the interstitial fluid outside the basal. These tight junctions are sometimes called blood testes barrier because they are functional to whereas they are something similar to a blood barrier, so they restrict movement of molecules between the compartments. So it's some type of regulations that stops everything from entering it. They don't allow large molecules inside of them, so it is a way to ensure that the right things are going into them. And so for the spermatogeneal cells, there are various stages and they are supportive of the sternatal cells. So the germ cells that undergo the metatic divisions to become sperms are found in these clusters in the end of the basal. And so they remain here for future production of the spermatogenea. Other spermatogenea start meiosis and become primary spermatites. So that is the divisions of them. Like if you see the 2N, so mitosis 1, mitosis 2, so it's just preparing the sperm to be able to fertilize an egg in the future. So the sternum synthesis of the pancreas molecules is needed for the spermatogenesis and spermogenesis. In addition, the FSH stimulates production of the androgen binding protein that inhibits this. So here is the spermatogenesis. So right here it shows the process of it becoming into a sperm cell, which can actually fertilize an egg. These are key, and there's various stages to this, as I previously mentioned, and it goes through mitosis 1, 2, and with here, the last stage is where it actually becomes the sperm cell. It can actually produce children if it's released into a female and find its way into the egg, and later on it will reproduce an embryo. And there are different hormonal controls of the spermatogenesis. So the hypothalamus is at the top, where that's regulating what's happening. We have the testosterone, and that's like the secondary effects of everything. So it's a process of like the negative feedback with positive feedback. So these cells undergo the mitotic division to become sperms, and they differentiate into sperms, and they move inwards towards the lubrial tube, which is continuously surrounded by the sterile cells. That's how they relate to each other with the tight junction, which have the blood testy barrier, which is something to like the blood barrier, which you find in other organs. So for the spermatites, it is the division and the production of mature sperm. And these are spermatids. These are able to reproduce those embryos and fertilize an egg, as I previously mentioned. And they have movements. They move towards the lumen, so they are able to move out the testes to go into the reproduction stage, as I previously mentioned. And so for spermogenesis, there are four different phases, as you can see here on the slide. We have the Gillicky, I'm sorry for my pronunciation, the Gillicky phase. We have the cap phase. We also have the formation of the tail, and we have the nutrition stage. So these are all the four stages that are important for the sperm formation in order to actually become fertilized. So without one step or another step, it won't be able to actually fertilize an egg to produce an embryo. And that is the end of the presentation for today. Thank you.